Hey, chemistry class, it's Monday, the 13th of April. We're going to do page 418 to 421, and you're definitely going to need your calculator, periodic table, of course, your pencil, and your paper. Work these problems with me. We're into the math side of chemistry again. Ain't that great? I'm on page 418. The definition of concentration is the concentration of a solution is a measure of the amount of solute in a given amount of solvent. So what do I mean? I mean, if I take this salt right here, what did I do with my salt? There it is. And I start to make a solution with this thing. Let's go ahead and ask you this question. I got that much solvent. Here we go. Is that a rather dilute solution right there? Is this a little bit more concentrated? So what does the word dilute mean? Not very much solvent in a given amount of solvent. Not very much solute in a given amount of solvent. So what does concentrated mean? Lots of solute in a given amount of solvent. That's only difference, the only difference. Okay, dilute and concentrated. Now, it's unrelated to whether or not it's saturated. Because you see, if I have that much water, go ahead and take some water again, and I take a material like cornstarch, that has a very low solubility. In other words, you can't get very much of it in. That might be it. It might be, once I stir that around, it might be saturated with that much cornstarch, just that much. So we would say it's a dilute solution that is saturated because it holds all that it can hold because it's very low solubility. What did I just say? I just said that dilute versus concentrated only means how much solute there is in the particular amount of solvent. It has nothing to do with whether or not it's saturated, because it could be saturated with a very little amount of hardly soluble or insoluble material. That's said on page 418 if you want to read it for yourself. So then how do we gauge how concentrated this is? How do we gauge the concentration? Well, we have to figure out how many grams of solute, and then we have to evaluate how many liters or milliliters of solvent. Oh, no, wrong. Of solution as a whole. Okay. So let's just take a look at that. Molarity. This is a formula. Write this down. Molarity equals moles of solute per liter of solution. There's our formula right there. Moles of solute per liter of solution is called molarity. And molarity is a capital M. So let's go on over here and take a look at 419. I will discuss how you mix these solutions in a volumetric flask tomorrow. And you know what? I didn't bring in home any volumetric flasks, so I can't even demonstrate it. Go to page 420. You have 3.5 liters of solution, so write this formula down. Okay, this is sample problem A on 420. You have 3.5 liters of solution. And it says you've got 90 grams of salt, sodium chloride. What's the molarity of the solution? 90 grams. Does 90 go up here? Does that say mass or does that say moles? So what is moles? Well, 90 grams of sodium chloride, grams of sodium chloride go down here, so they'll cancel. And moles of sodium chloride go up there, because that's where we're headed. And 1 mole of sodium chloride is how many grams? Well, sodium is 23 and chlorine is 35.5. So what's 23 divided by 35.5? I'm going to cheat and look, it's 58.5. And when you take 90 divided by 58.5, you can get the moles of sodium chloride, which is 1.54. And those moles of sodium chloride are going to be put right over there. So you got moles on top, you got liters on the bottom. 1.54 divided by 3.5 is 0.44 molar. So they say the molarity of the salt solution is 0.44, capital M for molarity, 0.44 molar NaCl solution. That tells you the extent of the concentration. It's easy. It's a plug and chug. That's the way I like to do it. I like to remember this formula right there. Molarity is moles per liter. Moles of what? Solute. That's the salt. Liters of what? Solution. That's the salt water. Pretty easy, isn't it? All right, let's do another one. Sample problem B. Same thing, except you're looking for a different unknown. Sample problem B says you have 0.8 of a liter. And 0.5 molar hydrochloric acid. You know what this is going to be? X. And what are we going to do? We're going to cross multiply. So X times the invisible 1 is X. And 1/2 of 0.8 is 0.4. And that is going to be this thing here, moles. That's what they're looking for on sample problem B. 0.4 moles of HCl. Is that easy or is that easy? Okay, sample problem C. Let's take a look at that. To produce 40 gram, blah, 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 blah. What is the volume of the solution needed? Okay, now here's what I'm going to do. How did we calculate moles? Well, let me ask, how many moles of carbon do you have if I give you 24 grams of carbon? Well, what's 24 divided by 12? Is it 2? You have 2 moles of carbon. If I give you 12 grams of carbon, that's 1 mole. If I give you 24 grams, that's 2 moles. And what you know what you did in your head? You said that moles is equal to the mass that I give you divided by the molar mass. I gave you 24, and you know the molar mass is 12 off the table. 24 divided by 12 is 2 moles. So I'm going to change this formula. And instead of writing moles up there, I'm going to write mass divided by molar mass. Wait a minute, Mr. Schultz, that's not fair. There's a capital M for molarity and a capital M for molar mass. I know. It's the way it works. Now, on this problem, it looks like we're talking about a 6 molar solution. And it says that they want to know how many liters, what's the volume of the solution is needed to give you the 23.4 grams. .4 grams. And what is the molar mass of the K2CrO4? Well, let's look down here and find out. It's 194.2. I normally round things off, don't I? And the number of liters is what we're looking for. And how are you going to do that? Here's how you're going to do that, guys. You're going to cross multiply. You're going to cross multiply. You want to call liters X? You like X's, don't you? Okay. Is there an invisible 1 down here? So 6 times X equals 1 times that fraction, 23.4, divided by 194. Let me get this out of here. Almost done. Now what are we going to do? Is there a 1 under here? Of course there is. So you're going to cross multiply again. 6x times 194. What is 6 times 194? I got to get my little calculator here. Almost done. Hang in there. After this, you get to do some math. Isn't that great? 6 times 194. 1164. That's 1164x. Is 23.4. Now you're going to divide both sides by 1164. And you're going to get X is 23.4 divided by 1164, which, what is it? They got 0.02 liters. That's what I'm looking for. Let me verify that they got it right. 23.4 divided by 1164.02. See ya.